All right, guys, so we are now getting into section 8.3, which is a t-test for me. I wanted to take our time as we started chapter 8, because now that we did these next two sections, the steps that we're going to go through become a little bit easier. So what's changing now is the fact that our population standard deviation is not given to us, and then in section 8.4, we're going to go through the steps, but we're dealing with the proportion. Much like back in chapter 7 with confidence intervals, we looked at the z distribution, t-distribution, and then confidence interval for a proportion. So now recall with the t-distribution, that's again when sigma or the population standard deviation is unknown. Remember, it's a family of curves based on degrees of freedom, and every curve is still bell-shaped and symmetric with respect to the mean. What's going to change here is our t test value, as well as how we find our critical values, because we're using, when we use the Inspire, we're going to use some different options now because we're dealing with the t-distribution. So here the only thing that's changing is we're using an S instead of the sigma, and so that's going to give us a slightly different t test value than versus the z test value. Again, degrees of freedom is always our sample size -1. As we saw back in chapter 7, assumptions for the t-test for mean when our population standard deviation is unknown. And we're going to want to state these assumptions in our paper, your research report as well. So for any of you, and I know at least one or two of you did a research report where you stated an average, this is the hypothesis, the section for the hypothesis testing that you're going to want to use in your paper. So you're going to want to make a statement that the sample is a random sample. Either our sample size is greater than or equal to 30, which I think everybody's was, or the population is normally distributed if n is less than 30. All right, so to revisit the traditional method, but now applying it to a t-test for a mean, number one, the step one, that stays the same. We state the hypotheses and identify the claim. When we go to find the critical value, we're going to be using some different options on our calculator. So that's going to change a little bit, and then find the t-test value for the mean using the t-distribution. Once we compare steps 2 and 3 together, that's where we make our decision, just as we did so in section 8.2, and then we summarize the results. All right, so I just had this handout I just scanned in here. I'm going to post this as a separate PDF if you didn't already see that, if you wish to print that out before we get to this section so you guys can fill this in. If not, take the time, please copy it down in order to fill in these answers here. All right, so for 1, 2, and 3, all I'm asking for, we're just going to practice finding the critical values again for using the t-distribution. So on the Inspire, we are now on a calculator page going to use menu 556. Notice it says inverse t, so that's what we have to use here. So if you want to pause the video at this point, copy the problems down, go ahead and try these. Notice the degrees of freedom are already given. I'm not giving you the sample size, I'm giving you the degrees of freedom. So go ahead and pause this, give these a try, and then continue playing to see what you're coming up with. All right, so for number 1, our critical t value for alpha is 0.01, degree of freedom 22. This is a left tail test, so that little area, that 1%, is shaded on the far left end. So that's the area we want to type in. So if you go to menu 556, you're typing in a 0.01, degree of freedom is 22. So you should be getting a critical value that's equal to a negative. We should expect a negative result, and about a 2.51 when we round to the nearest hundredth. For number 2, this is a two-tailed test, so our alpha value is split. So we need to enter in alpha over 2, which is really 5%. So we could type this in just as our area. Again, go to menu 556, type in 0.05, degree of freedom is 18. So our critical value, we could expect to get 2 of these, so we include the plus or minus, and we should be getting a 1.73 for this. And for number 3, critical value for alpha equals 5%, degree of freedom is 28. It's a right tail test, so this little 5% of the area is shaded in to the right, which means 95% is to the left of this critical number. So we need to type in a 0.95 for area. And when you do this, we should expect a positive number. Our critical value should come out to be a 1.70. So hopefully you guys did okay with this. Again, if you have any questions, if you don't have a calculator, you could still get one from me. Please let me know. If not, please continue to use the websites that I gave you as a way to do these calculations. All right, so for numbers 4 and 5, we're going to go through the traditional method of hypothesis testing for these. So pause the video again, read over number 4, use it to state your hypothesis and find your critical values for right now, and then you can pause again before we find the other 3 steps. All right, so looking at this, notice the question here, is there enough evidence to reject the investigator's claim? So the word reject is a big clue. We only use reject when we're dealing with the null hypothesis. So that means the claim is going to be the null hypothesis. Notice there's no other mention of something being greater than or less than. So the researcher is claiming that mu is going to equal, in this case, the 16.3. Since we have no other number or no other comparison, our or alternative hypothesis is going to be that it's equal to something other than 16.3. So for step 1, the null hypothesis is going to be mu is equal to 16.3, and this is the researcher's claim. The alternative hypothesis is that mu is some other number other than 16.3. So now step 2 is the critical value. So this is a two-tailed test, which means we need to type in alpha at, so we need alpha over 2 to figure this out. So we're going to have a 0.025 that we type in for the area. So our critical value should be coming up as a plus or minus 2.26. Just go ahead and see if you were coming up with that. Our degree of freedom, if we have a sample of 10 weeks, our degree of freedom is 9. So we should be getting, in this case, you get a negative on your calculator, but no, it's a plus or minus 2.26. Step 3 is the test value. Make sure that you either say the test value equals or t is equal. In this case, we're going to have a 17.7 is the sample mean minus 16.3 divided by our standard deviation. Notice it says sample standard deviation. That's key, telling us we need to use a t-distribution. It's either going to say sample standard deviation or standard deviation. That implies that we use the t-distribution. It has to say population standard deviation to use the z-distribution, the normal distribution here. So we'll have 1.8 divided by the square root of 10. So our test value comes out to be 2.46. Our decision here then, when we compare 2.46 to positive 2.26, so just making a quick sketch here. So let's say this is our critical value of 2.26. 2.46 is showing up to the right of that, so it is in the critical region or the rejection region here. So our decision is to reject the null hypothesis, and our summary. Again, we want to use the statement, and again, for our homework, it's okay to just kind of stop, that we could say there is enough evidence to reject the claim. Since we have the claim identified in step 1, the claim is that the average number of infections is 16.3. All right, for number 5, I'm giving you raw data here. So on your calculator, go ahead to a list and spreadsheet and type this in. If you don't have your calculator, you can use a Google Sheet to do this. Pause the video, see what you're coming up with for your sample mean and sample standard deviation. Again, we want to use S for the sample standard deviation. All right, well, if you notice here, an educator claims that the average salary of substitute teachers in school districts in Allegheny County, Pennsylvania is less than $60 per day. Because it's less than, it's the alternative hypothesis that's going to be our claim. So step 1, our null hypothesis is that mu is equal to $60. And the alternative hypothesis is that it is going to be less than 60. And then this is our claim, or the researcher's claim. All right, for step 2, we want the critical value. So this is a left-tailed test, so our alpha that we're going to type in is the 0.10. So go ahead and do that, and we should be getting a negative 1.415. Our degree of freedom, if we count all these up, we should get a 7. So critical value is a negative 1.415. Step 3, our test value is t is going to equal our sample mean. Oh, we have to show that off to the side. So hopefully you guys were finding x bar. We're going to round up to one more place value here. Should have been 58.9. Our sample standard deviation should have been 5.1. So hopefully you were finding those. All right, so using that, we'll get a 58.9 minus 60 over 5.1 divided by the square root of 8. And we should be getting a negative 0.61 for our test value. Again, if we make a little sketch, here is our critical value at negative 1.415, and our test value is at a negative 0.61, so we're somewhere up here. So if it fell to the left, that would be in the critical region, so this is the area where we would reject. So then our decision is to not reject. The null hypothesis. And then our summary is that there is not enough evidence to reject the null hypothesis, or we could say that there's, let me rephrase that, there is not enough evidence to support the claim. That will be a lot easier. Because our claim was the alternative hypothesis, we're saying there's not enough evidence to support that. And again, that the claim was that the average salary of substitute teachers is less than $60 per day. So there is not enough evidence to support the claim. All right, so those were just 2 examples looking at the t-test compared to the critical value, the traditional method. Now let's take a look at the p-value. So looking at a couple examples, 6 and 7 just has, I'm having you practice finding the p-value given a certain t-test value. So again, we're using a different option on the calculator. And then number 8, we're going to use the p-value method to conduct this hypothesis test. So now on the calculator, we're looking at menu 555. We're not typing in area, we're typing in the test value, because remember, for the p-value method, we don't find the critical value, we find an area and we compare it to alpha. So for 6, go ahead and pause this if you want to try it on your own. It's very similar to what you guys were just tested over, but again, we're using the menu 555 feature. All right, so here we want to find the p-value when the t-test value is 2.056, the sample size is 11, and then the test is right-tailed. So what the type of tailed test we're looking at is going to tell us, is this 2.056 our upper boundary or our lower boundary. So when you guys go into menu 555, because this is a right-tailed test, this is telling us that our test value here, I'm going to say, is 2.056. So we're looking at this area over here is what we're going to find. So there's no need to double it. This isn't a two-tailed test, just a right-tailed. So the 2.056 is our lower boundary. So type in 2.056. The upper bound is going to be that infinity. And our degrees of freedom is 10. So we should be getting that the p-value is equal to a 0.033. Hopefully you were coming up with that. All right, for 7, this is a two-tailed test, so we have to double the area we're getting to give us our p-value. It's not that our p-value is each area. We're not doubling a p-value, we're doubling the area, and that's equal to our p-value. So here, if we're looking, we have a two-tailed test, so we've got a little bit of area to the left and the right, and the t-test value, let's say right here, is 2.983, or over here, you can put in a negative 2.983. So because the calculator is sort of set up default to show the negative infinity first, we could do that. We can go to menu 555, leave the negative infinity there, but then type in a negative 2.983. And our degree of freedom is going to be 5. So I'm just pointing out here, I'm going to say this area right here is a 0.0153. So we need to double that. So our p-value is going to be double this 0.0153, which gives us 0.0, we could just say it's 0.0306. All right, so again, revisiting the p-value, the only thing that's different is we're using the menu 555 or menu 556 with this. All right, so our last in-class example, again, if you want to pause this and try this on your own and then check the steps, feel free to. We are using the p-value method here, so remember, step 2 now is to find the test value. We do nothing with the critical value. Once we find the test value, we use it just as we did in example 6 and 7 to help us determine the p-value. We compare it to the alpha in this problem, which is 0.05. So go ahead and pause this, read this over, and then continue playing. All right, so here a physician claims that joggers' maximal volume of oxygen uptake is greater than the average of all adults. A sample of 15 joggers has a mean of 40.6 milliliters per kilogram and a standard deviation of 6 milliliters per kilogram. Notice it doesn't say sample, but more importantly, it doesn't say population, so this is the sample standard deviation. If the average of all adults is 36.7 milliliters per kilogram, is there enough evidence to support the physician's claim? So since we're using support, that alternative hypothesis is going to be the claim. So step 1, the null hypothesis is that mu is equal to 36.7. And the alternative is that mu is greater than 36.7 milliliters per kilogram. And again, this is our claim. So now step 2 is to find the test value. So T is going to equal the 40.6 minus the 36.7 over our standard deviation is 6 divided by the square root of 15. So go ahead and calculate that. You should get 2.52. Okay, now we want to use that to find our p-value. So step 3 is the p-value. Since this is greater than, it's a right-tailed test. So this test value here is about 2.52, which means the area we're looking at is shaded to the right of it. So we're using this as a lower bound. So if you go to menu 555, type in our lower bound is 2.52. The upper bound is the infinity. Our degree of freedom, we're looking at 15 joggers, so our degree of freedom is 14. And our p-value should be a 0.012. Again, alpha is 0.05. So our p-value is less than alpha, which tells us for step 4, we reject the null hypothesis. So it's like we're kicking out the null hypothesis, which means we can support the claim. So our summary, step 5, we could just say there is enough evidence to support the claim. And again, that claim is that the jogger's maximal volume oxygen uptake is greater than 36.7 milliliters per kilogram. All right, so again, now we're just shifting gears a little bit into the T distribution, slightly different features on the calculator that we're using. So I may even give you guys a third day on this as well, so taking it to Friday, but by Friday I should have the answers posted. But I want you guys to get caught up with that quiz. Looking at this, take your time because the worksheet that I'm giving you, let's see, has about 10 problems, but take your time with it. I know it's a long process to just sit down and do everything at once. As always, I'll have this posted as a separate PDF, and email me if you guys have any questions.